And I think I'll just dive right into the first speaker, who is Randy Smith of the Southwest Florida Water Management District. I see his pocket up here. He's going to talk about Lake Hancock project that is sponsored by the Southwest Florida Water Management District to improve low flows and water quality in the Upper East River. Randy.
Thank you very much. Good morning. I'm Randy Smith. I'm with the Water Management District. The Lake Hancock projects have been a focus for the district for over a decade now. It's a large effort to involve pretty much every aspect of the district, a lot of local stakeholders, and we're coming to the end of that effort, and I just want to give you guys an update on that and share some of our success. Lake Hancock is a 4,500 acre lake located in central Polk County. It's a relatively shallow lake with a mean depth of about 5 feet. It makes up the headwaters of the Peach River, which extends about 120 miles downstream and discharges into Charlotte Harbor. Some of the issues that the Upper Peach River faced that kind of brought about this project are not meeting low flows in the Upper Peach River and poor water quality. Lake Hancock is characterized as a highly eutrophic lake. It's well above the threshold of the 10% worst water quality values in the state of Florida. Really, two projects that I want to focus on is the lake level modification project. And that project involved raising the lake level in Lake Hancock to store wet weather flows that could then be used in the dry season to meet the minimum flows and levels. To accomplish that, the district had a large land acquisition effort and had to do several conveyance improvement projects around the lake that were impacted by raising the lake level, and had to replace the P11 outfall structure that was located at the South Creek. The other project is the Outfall treatment project, which is a 1,000-acre treatment wetland that was constructed to treat water discharging from Hancock. Goals of the lake level modification project are to complete critical element of the SWFWMD recovery strategy. And the district had to develop a recovery strategy because the minimum flows and levels in the Upper Peach River were not being met. The state mandates that the district set minimum flows and levels, and if those levels aren't met, the district must develop a recovery strategy to meet those minimum flows and levels, and that basically was the SWFWMD recovery strategy, and the lake level modification project is a critical component. The project specifically is going to increase the number of days that the Upper Peach River meets the MFL from 70% to about 89%. So currently the MFL in the Upper Peach River is only met about 70% of the time. Rule states that you must meet it 95% of the time. So even with this project, we're going to fall a little bit short of the rule, and we've known that this is as much as we can get out of Lake Hancock. In addition to meeting the MFL, we'll also be able to provide the 17 CFS of recharge sink features located in the Upper Peach River. There's a section of the river that's basically like a sieve. There's a picture in the lower left corner. There's cracks and crevices, and really it's a losing stream at that part of the river. Project will also preserve about a little less than 5,000 acres of floodplain, and it will restore the historic lake level of the Lake Hancock. Historically, the level operated about a foot to 2 feet higher than its current operating level of 98.7 feet. And the picture in the upper right, that's what we're trying to accomplish. That's the river. That's the Peach River right there with no water in it. So this project will hopefully alleviate us having to deal with that. Raising the lake level a foot and a half required the district to purchase quite a bit of property. Over 8,000 acres of property had to be acquired, 74 parcels, 30 homes. Some of those parcels were in fee, some were for inundation easements. All land acquisition was completed in 2012. A benefit, or a secondary benefit to the project is with all of that land that we had purchased for the project, there was a lot of opportunities for recreation that the property could be utilized for. Bridge Trail, which is going to be a loop from the Fort Fraser Trail, runs along 98 on the west side of the lake, and will loop completely around the lake. It's in design right now. The district in partnership with Polk County will connect to a whole series of trail systems that they already have in place on Circle B parts. There's some conveyance improvement projects that need to take place. We had a cemetery nearby Lake Hancock that's going to be impacted by the lake level. We had to build a stormwater pond, a pump station, and raise a berm around that cemetery. The project is complete. We had to do some improvements along Highway 540, besides the culverts, increasing some conveyance in that area. We had an impact to a pond along the Old Parkway we need to take care of. This area right here, the Lake Lena Kasha area, is interesting. Lake Lena is coming in from the north, and it used to route through the sluice system into Lake Hancock. Sometime around the early 90s, a private venture owned this property in red and was going to turn it into a private fishing facility. And they rerouted Lake Lena through this constructed wetland into these series of pits on the east side of the lake that eventually do route back to Lake Hancock. However, the first pit that water reroutes to has enormous sink losses. So we found out that the majority of Lake Lena was no longer making it to Lake Hancock, which kind of contributed to the lake levels not being as high as they need to be, not having sufficient levels to release water and address. And the final improvement was improving some conveyance through this series of pits here, which drains some nearby developments. All of the conveyance improvements have been designed and permitted. The first two are complete. The last three are being grouped as one project. We have a contractor on board. We should start construction in April. We should complete construction in September, and that will wrap up the Lake Modification project. The structure on Saddle Creek, the upper picture is the PLF structure at a current operating level of 98.7 feet. The structure was built in 1965. It served its purpose. We had to replace that structure with a new structure as part of this project. The old structure had two 20-foot lift gates, and the new structure is going to have two 20-foot lift gates and two 10-foot drop gates. So we'll have better control on the releases from Lake Hancock for flood flows and low flow releases. Construction on the PLF structure began in November 2011 and was complete in May 2013. The picture on the right, you can see was about 8% complete construction of the new structure. You can see the old structure in the bottom right-hand corner. It had not been removed yet. It's a little slideshow to give you a picture of the activities that went on over that 2-year period. We had to construct the bypass channel throughout Saddle Creek flows around the construction area. Lucky enough to get good help from Mother Nature during this time period, because if we would have gotten a large hurricane, we potentially could wipe out our construction project in the process here, so we got some good fortune there. This picture right here was during demolition of the old structure, and you can see on the top of the back, this is right before they demolished the old structure. You can see there's a lot of water upstream of that structure. Here it's drained. The contractor used an aqua barrier upstream of Saddle Creek. Basically, it's a big balloon that filled with water and off the river, and again, we're fortunate enough to get good weather during that time, so we complete the old structure. And this is what the site was like today. The PLF structure able to accommodate raising lake level up to 100 feet, creating that wet weather storage that would be used to meet those levels. This will also be the crossing for the Lake Hancock Heritage Trail.
The Outfall treatment project, 1,000-acre treatment wetland began construction on the south shore of Lake Hancock. Goals are to reduce annual nitrogen loading by 27%. So that's going to remove about 174,000 pounds of nitrogen a year, which works out to about 27,000 bags of 20-pound bags of fertilizer. So that's a lot of nitrogen being removed in the system. And some analysis on that is that is going to offset the loads expected for about the next 19 to 20 years. So it's consistent with a whole line approach out for the next 19 years to contribute nitrogen to the system. We expect a water quality shift from Ford to Bear and the Upper Peace River. That upper 20-mile portion of the river is poor water quality coming from Lake Hancock. So anything we can do to improve water quality at the headwaters is going to be felt all the way through down Sharp Harbor. And that's another focus of the project is to protect Sharp Harbor, our storm priority water body, and Estuary national significance. We did some cost benefit analysis on this project. The 8 large-scale stormwater retrofit projects that were primarily constructed to address water quality. The district had focused on in years past, and we determined that we were getting about $18 per pound of nitrogen removal for the projects. The system, we're going to get about $6 to $8 per pound of nitrogen removal. So the project is very cost effective. This is a photo of the Outfall treatment system in about the 1970s. You can see that it already has the same configuration as what I'm going to see in a minute when I show you that picture. But basically, we use the berms and everything that were in place from the mining activities that occurred here. This was an old place settling area from mining activity that occurred from the 50s through the 70s. We were able to use a lot of the berm that was in place for the project. This is a cut fill map, 1.8 million cubic yards of material that is used around these cells to provide the gradient, proper gradient to get sheet flow across the cells. In addition to that, we're going to import about 300,000 cubic yards of material to shore up some areas of berm that weren't adequate. And it's over 8 miles of berm around this one. This is a planting scheme for the project. The horizontal lines swimming across the cells, those are the planting strips. The 1,000 acres, we couldn't plant all 1,000 acres, so we made some pilot studies. The cost-effective approach was to plant these 35-foot wide strips separated by about 200 feet across the wetland area. And those were infill over time, and that was the cost-effective approach. Over 500,000 plants were planted in this wetland. The little circle bullseye areas are the cypress zones that are also planted for the project. And the darker pink areas along the top, those are the deep areas within the wetland. Those will be stocked with southern iodide and coontail to provide additional water quality treatment. There were some hardwood islands that were in place that a few that were left within the wetland just kind of diversify the habitat there. This is how the wetlands can work. It's going to pump water from Lake Hancock to pump stations to pull out water from Lake Hancock, and it's going to merge to a splitter box, which is going to split water between cells 1 and 2 through these rim dishes that will allow water to sheet flow through cell 1 and 2 to these internal structures that then discharge to cell 3, down to the polishing cell, and then discharge to the outfall structure into south 3 and ultimately Peace River. This is a close-up of the pump station. It has 3 pump bays, 2 active, 1 standby. There's 30 CFS pumps in each of those. The max capacity of the wetland is 60 CFS at the pump station. We're factoring in about 8 CFS of ET losses, so we'll be able to discharge about 52 CFS out of the wetland system. This is a photo of the outfall structure. It has a large 150-foot wide aeration structure to provide some relation to the low yield water that's going to be discharging from the system. This is a photo of the 1,000-acre footprint for the wetland early on in construction. And this is a photo from last month. So you can see the strips that we planted, and the deep zones, and the cypress. Construction began in October 2011 and was completed in December 2013. We're in kind of a plant establishment mode right now. We plan on, right now, the wetland cells are just being maintained about a foot depth to help establish the plants. We are taking some water quality samples out there monthly right now. Intake concentrations from the lake are around 6 to 8 milligrams per liter total nitrogen. And we're at the internal structures between cell 1, 2, and 3, we're getting reductions below 2 at that level, and then at the outfall structures below 1. I do want to asterisk that with it's not a flowing system right now, so some of that could be pollution, or it could be rainfall moving a little bit, and it does flow a little bit when we do raise the lake, so it's not exactly at the level, but we do feel that the preliminary results are promising. We anticipate ramping up to weekly monitoring this summer when we start flowing through the system. Project cost. There's a lot going on, big footprint, huge cost. Main acquisition loan was $130 million, over $130 million. PLF construction was $6.5 million. And the conveyance improvements and modeling and preliminary work that we did totaled $7 million. The outfall treatment project was $24.5 million. So when we come in just under $170 million on this project, when we first started looking at this project over a decade ago, some of the preliminary estimates exceeded $250 million. So as we moved into better information and order approved the project, we told them that we think we could do the project for $175 million. So we're going to meet that target. There's a lot more information available on Lake Hancock if anybody's interested. Goes to the Watershed District webpage and projects, Lake Hancock. We've got construction progress over the monthly, a lot of information, background information on the projects, and all of the reports and studies that were developed for the project are also available online. Before I move to questions, this was a big project, and I want to take a second to recognize a few people. Gene Hagberg, our center section, managed the Outfall treatment project. Scott Cassidy, engineer in our project management office, managed the P11 projects. Michael Peck, engineer in project management office, doing technical support on all the conveyance improvement projects. And Gary Downing, our senior engineer, has been with the project since the beginning and has really been the main technical person on this project. And with that, any questions?
I noticed in your aerial, between the strips, there was something green in the area. Is that just algae, or is that something else recruiting by itself?
This area right here, this area. No, there's no algae. I think this picture was taken right as they started to fill the cells up. So I think that's just vegetation that hadn't died off yet. It was growing in there. The chlorophyll counts, time counts are going way down in this wetland. So you see the lake right close to that is green, and the water inside the wetland is not just like this. So the chlorophyll is really an algae.
Thank you.
I just wonder if the trail around the lake is going to go out around the treatment pond too.
Yes, it is.
Well, up at the north end of Lake Hancock, where you built some water treatment stuff, we're getting tremendous numbers of migratory birds, and a lot of people come out and want to see them. And
Yes.
so I think it would be great if the trail goes out around that point, because you're going to get them there too.
It is, and the county is driving the trail. Let's see if I can really have a pointer, but yes, the trail is going to come in and it's going to ride along the northern berm of the Outfall treatment wetland and go all the way around the lake. And you do mention the bird counts. We have some little Audubon groups that are going out there, I think every other month, and taking tours, allowing them to do that. And at the annual Christmas bird count out there this year, they counted over 100 different species of birds. There was over 7,000 white American white pelicans on Lake Hancock at that time.
I saw.
It is a premier bird place for people. And,
I think your new wetland will be too.
the wetland is some birds are nesting along the shoreline right now, and I think that would be a tremendous amenity for people that like to bird watch and such. So the trails that are designed right now, I think they plan on having it completed for next summer. So yes.
Thank you.
What was the primary land use designed for the area that was acquired? In other words, what was that going to become if it had not been acquired for this project?
This portion on the lower right-hand land use was actually an active DRI property that the district maintains. So some of that property is going to be surplus. We're maintaining a DRI to potentially recoup some of our land acquisition costs for this project. It's altered land that was mined. The other land use was either ag or residential. We have to acquire 30 homes with this project. So we have a mixture of agriculture and residential property and altered mine.
Thank you.
Turn the mic on, please, John.
Hi. Is the ongoing operational cost pretty expensive, or have you minimized that in some ways?
Yeah, it is expensive. The initial estimates for annual maintenance and operation of the wetland treatment system was $700,000 a year. We've refined those costs over time, and we think it's going to be closer to about $450,000 a year. So just annual and then is going to be quite expensive.
Is there an expectation that the lake itself will ever improve in water quality?
Not by itself.
So this is just the water leaving. This is a treatment process like wastewater treatment plant or something. Protect the river, doesn't fix the lake.
Correct. And early on in the process, probably in the late 90s, I think, as the district looked at that. Was it a better approach to try to treat the lake or to treat the water coming out of the lake? And it was definitely more cost effective at this time to treat the water coming out of the lake, but still have that in the future as the technology is advanced and that it's more cost effective, that you would potentially pursue partnering with somebody to do some in the lake cleanup as well.
Husband?
What does the maintenance entail? Is there vegetation management and stuff? What?
Yeah, there's going to be some vegetation management. There's monitoring. We're going to do weekly water quality monitoring for years on this project.